Hi everybody, welcome to the Chapter 7 review. Chapter 7 included the Pythagorean theorem and also trigonometry. So this was a very important chapter, and as you know now, there was a lot of work that we did afterwards that was dependent on the Pythagorean theorem and also trigonometry. So this was a very key chapter for us, and it will be well represented in the final. So here are some keys to success. Please know SOHCAHTOA. Okay, the sine theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And tan of theta equals opposite over adjacent. Please know this. Okay, you can write it down in your notes, which you can have in the final, but make sure you know where to find it during the final. Nothing's more frustrating than having a pile of notes and need to have an answer to a question and you can't find it in your notes. So please organize that well. Okay, also know the Pythagorean theorem. Okay, we know it formally as a squared plus b squared equals c squared, but please also remember that these can be any different letters. This could be r squared plus s squared equals t squared, or any other letter, okay? But be able to recognize that when you add two variables squared, it equals the third variable squared if those two, if those are all part of a right triangle, okay? Pythagorean theorem does not work on any other triangles but right triangles. Okay, please know the parts of a triangle, know which one is the hypotenuse. Okay, the hypotenuse is always the longest. And make sure you can identify the two legs. Okay. Know the different types of triangles, so acute, obtuse, right triangles, and scalene triangles. Know what those mean. Know your special triangle measures. So we have 45, 45, 90 degree triangles, and we have 30, 60, 90 degree triangles. Those are special triangles that have the measures of their sides are very specific. They're very easy to find. And if you come upon a problem that uses special triangles, but you forget that it's a special triangle, you may be able to get the problem right, but it will take a lot longer. Okay, so recognize when it's a special triangle. Okay, what it means to solve a triangle, we'll talk about that a little bit. And please bring your green trig table to the final. This is super important. Okay, you will not be able to use your phones during the final, and the calculators we have in the class do not have the trig functions. So please bring the green trig table, and you're not going to be able to share calculators or anything like that. So your safest bet is to bring the green trig table to the final. Also, get used to drawing pictures on your scratch paper. That generally means the difference between partial credit and no credit for a question, because when we have a multiple choice fill in the bubble test, okay, and you mark it wrong and you put the wrong answer there and don't give me any notes or anything, I have to mark it wrong and you lose all the points on the problem. So if you do use scratch paper, do your work on scratch paper, draw pictures, that sort of thing, okay, I can look at that and I can say, oh, okay, well, this was just a really teeny mistake, and maybe I'll take away just 1 point and give you the credit, the rest of the credit, okay? But if I don't have those notes, if I don't have that scratch paper, not your notes, sorry, the scratch paper, I can't do that. So you'll get more points if you use scratch paper and turn it in at the end of the final. Okay, so we're diving in here. Which equation is not correct? Ah, go away. Going back. Okay, which equation is not correct? Okay, notice a little bit of a trick there. It's not asking which is correct, it's asking which is not correct. And it tells you that the answer is B. Well, why is it B? Because if we look at this triangle, we know that these equations look like the Pythagorean theorem. And so if we were to just write the Pythagorean theorem, r squared plus s squared equals t squared. Okay, why is t on the right-hand side here? Because t is the hypotenuse. It has the longest length, and it is also directly across from the right triangle, or the right angle. So whatever letter is here, okay, is always going to be the hypotenuse. And then r squared and s squared are our two legs, and they can be in either order. You could do s squared plus r squared, or r squared plus s squared, and you'd be fine. Okay, once you understand this, the rest of this problem is just a matter of algebra. Okay, so let's look at A. So if I have s squared, if I try to put s squared by itself, okay, I can move s squared to the right, and I'm just going to do one of these, okay, but it becomes s. I can subtract s squared from both sides, okay. I can then move t squared to the left side, okay, plus r squared. Okay, now if I multiply all this by -1, oh, here, I'll write that up there. And I come up with t squared minus r squared equal s squared, which is A. So A works. Okay, it turns out C and D work. What doesn't work about B is that if you start moving all this stuff around, okay, it does not equal, s squared does not equal to t squared minus r squared, or plus r squared. It is t squared minus r squared. Okay, so that is wrong. So the equation that is not correct is B. These problems are tricky, and if you see one on the test, they can take a little while, so make sure you leave time for it. Okay, now here, remember, you're going to have an exam set of questions, and you're not going to be able to write on that paper. Okay, you're going to have to write on your scratch paper. So this is a perfect case where you would want to draw a picture. Okay, so a 5-foot ladder leans against a wall 7 feet from the base of the wall. Yeah. Okay, so here's my wall. Okay, wall. Okay, here's the ground. And here's my ladder leaning up against the wall. Here's my ladder. So now it tells me that the 25-foot, the ladder is 25 feet. Okay. And the ladder is 7 feet from the base of the wall. So we know this is equal to 7. And it wants to know how high up the wall does the ladder touch. So this is what we're looking for. So we know walls generally are perpendicular to the ground. Hopefully. If they're not, you have a problem. So this is a really nice example of where we can use the Pythagorean theorem. So if we have, let's call this guy B for building. Okay, so if I have b squared plus my length here, 7 squared, the ground, it should equal the height of the ladder squared. Okay, because this is a right triangle. So we b squared plus 49 equals 625. Okay, w squared equals 49. No, what am I saying? Sure. Equals 576. Okay, if you take the square root of 576, you get 24. And so that's answer A, just like we said. Okay, so if you came up with 18, 20, or 21.5, you did something wrong. And so that's the purpose of these, of giving you the answers, is that you can check yourself and you can figure out how to do the problem correctly. Okay. Okay, find the area of a rectangle, D. Okay, the first thing you're going to need to remember is how to find the area of a rectangle. So area is equal to length times width Okay, so how do we figure out our length times width? So here, we know that here's going to be our length. Here's going to be our width. Okay, we know this part of our length is 8 inches. So right off the bat, we'd love to say that this part, the top part here, is 8 inches also. But what gives us the ability to say that? And that is these two angles right here, or sorry, two lines right here. Okay, these two slash marks mean these are the same angle. And so if those lines, those are the same length. So if these are both the same length, then this line has to be the same length, and that is 8 inches. So now we know our length is equal to 16 inches. Okay, now what is our width? So we have to figure that out. And the best way to do that is use good old Pythagoras again, because we can take the example on the top, this top rectangle here, and we can make a triangle. And we know the hypotenuse is 10. It's given to us there, and we know that leg is 8. And so we have to find this leg. Let's call it A. So a squared plus 8 squared equals 10 squared. A squared equals 36. A equals 6. Okay, so W is equal to, or width is equal to 6. Now, make sure that you complete the area. Okay, we did find this length, but now we have to find the area. So the area is going to be length times width equals 16 times 6 equals 96. Okay, and there's our 96 right there. Okay. Okay. If the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is, okay, and here you're going to need to remember the rules for triangles. So we know that a squared plus b squared equals c squared is a right triangle. We know that a squared plus b squared, if we have a situation where a squared plus b squared is greater than c squared, then we have an acute triangle. And if a squared plus b squared is less than c squared, we have an obtuse. Okay. So let's see what we got here. So we're saying, and again, here's the absolute best way to draw a picture. So if the square of the length of the longest side, so let's draw the longest side and we'll call it C, okay, is greater than the sum of the squares of the lengths of the other two sides. So we'll call that side A, call that side B. Okay, so the square of the length of the longest side, so that's C squared, okay, is greater than the sum of the squares of the lengths of the other two sides. So the square of this side is A squared. This side, the square of this side is B squared, and it wants the sum. So A squared plus B squared is less than C squared. Okay. A squared plus B squared is less than C squared is an obtuse triangle. But look it, it's not equilateral, it's not right, it's not acute, it's obtuse. And so the only possible answer is D. It's none of the answers given. So that's a little bit tricky. But be confident in knowing that A squared plus B squared less than C squared is an obtuse triangle. So the answer is that none of those other answers are correct. Okay. So it's changing my notes here. So here you're going to have to do a little bit of graphing. And you can have graph paper, scratch paper if you like. If you don't, then you're just going to have to kind of draw it. So let's kind of draw it here. So an example of how that might look. Okay, here we go. So classify triangle ABC if the vertices are, okay, here's our x-axis, here's our y-axis. Okay, and this can be a sketch. It doesn't have to be perfect. So A is negative 12 in x and 5 in y. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we're there. And then we go up 5. 1, 2, 3, 4, 5. Okay, and we're right about there. Okay, B is positive 12, 5. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, up 5. It's basically on a straight line. Okay. And C is x equals 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and up 17. So it is, I don't know, we'll just put it over here. It's way up there. Okay. So let's draw our triangle. So is this a right scalene, an acute scalene, obtuse scalene, or none of the above? So obviously you need to know what scalene means. Okay, scalene means no sides are equal. Okay, and that's true. Okay, this guy A to B is obviously the hypotenuse, and it's longer than BC, and BC is shorter than AC. Okay, so it's obviously scalene. Okay, so none of these does not work. So the question is it right, acute, or obtuse? You have no reason to believe that it's a right triangle. The only possibility would be of a right angle would be here, and you don't know that. They don't give you that information. So, but it's pretty obvious that the smallest angle here is less than 90 degrees. Okay, it's smaller than 90 degrees. So it has to be acute scalene. Okay, if you had a triangle that looked like that and this angle was greater than 90 degrees, then you would have obtuse scalene. But that's not what you have. You have an acute scalene here. Okay. Find A. Oh, find X. And X, which is A. So this is kind of a tricky one. But you can do it. and it just takes a little bit of thought. So, what do we know? So we have 3 triangles here. It's important to notice that. So here's one triangle. Here's the big one. Okay, and we can define the big one as, this is our right angle. We'll use the Pythagorean theorem. X squared plus 8 plus 4 is 12 squared. Oh, no, that's our hypotenuse. Okay, we don't know what this guy is here, so we'll just call it C. No, let's not call it C. Let's call it B. Okay, x squared plus b squared equals 12 squared. Okay, now let's look at another one. Let's look at this small one here. Okay, and let's call that line A. So we have 4 squared plus x squared equals a squared. Okay, and now let's try another one. Okay, and then we have this guy here. Okay, so this one is a squared. Did I do that right? No, I didn't do the red one right. Let's do the red one again. Okay, our hypotenuse is x. So this is going to be equal to x squared, and it's a squared plus 4 squared. Okay, looks better. Okay, our blue triangle is a squared plus 8 squared equals b squared. Okay, the question is, what the heck do you do with this? So what we do is we have x squared plus b squared here, and then we have 144. So we have one equation, the red equation, that tells you what x squared is, and we have another equation that tells you what b squared is. So we need to put those together. So we have x squared. Okay, I'm going to change colors here so it's understandable. Okay, x squared is equal to a squared plus 4 squared. Okay, remember we're going, the big one was x squared plus b squared equals 12 squared. So we have a squared plus 4 squared plus a squared plus 8 squared, okay, equals, I'm going to square 12, so 144. So we have, if we add these together, we have 2a squareds plus 4 times 4 is 16 plus 64. Okay, so it equals 144. 2a squared equals 144 minus 16 plus 64 is 64. Okay. So a squared is equal to 32, and a is equal to 4 root 2. Okay. And so we know a is equal to 4 root 2. And so we plug that back in to the equation for the red triangle. So we're going to have a squared, which is 4 root 2 squared plus 4 a squared plus 4 squared is equal to x squared. So 4 root 2 squared, we square the 4 is 16. We square the square root of 2 becomes 2 plus 16 is equal to x squared. 16 times 2 is 32 plus 16 equals x squared. 32 plus 16 is 48. Equals x squared. X is equal to the square root of 48. Okay, none of the answers provided have the square root of 48, so you must have to simplify. Okay, and so if we start taking it apart, we can see that 48 is equal to 4 times 12. Okay, so we can take the square root of 4 is 2 and leave him out of the house, and you're left with 12. Okay, there's still 2 times the square root of 12 is not one of the answers, so we got to keep going. So we have 2 times the square root. Let's find some factors of 12. Okay, there's 4 again, so we can take another 2 out. That becomes 4 times the square root of 3. And there we go. There's 8. And that one's kind of tricky. There's a lot of algebra in that. Okay, so work with it, try it, and I can certainly answer any questions if you have it. Okay, we're going to skip number 7. Okay, so don't worry about number 7. Okay, number 8. My notes here. Okay, it says, in a 45, 45, 90-degree triangle, okay, remember what we talked about at the very beginning, here's your special triangle. The hypotenuse is how many times as long as each leg? So you remember a 45, 45, 90. So this is 90, this is 45, this is 45. And the rule says that the two equal legs, remember these are equal because it's a 45, 45, 90, okay, say those are x, and our hypotenuse here is going to be equal to x times root 2. Okay, and please have that in your notes so you can access it. So the question says, in this triangle, the hypotenuse is how many times as long as each leg? Okay, x is the leg. So the hypotenuse, which is the longest edge, okay, is x times the square root of 2. So the answer is B. Okay, the square root of it, the hypotenuse is the square root of 2 times as long as each leg. Okay. Number 9. Getting tired of red. Let's do green. Okay, so here we're going to get into some trig. And, well, actually not yet. We still have another special triangle. So notice here you've got a 30, 60, 90. Okay, 30, 60, 90. Okay, special triangles. So remember that the rules for the special triangle are, okay, this is 30, this is 60, here's my 90. Okay, my smallest leg is right there. Let's call it x. And the length of the other leg is x root 3. And the length of the hypotenuse is 2x. Okay, so that's our general rule. So here you're given that this side here is 6 root 3. And if you turn that around, okay, you get this, okay, is equal to 6 root 3. So you take away square root of 3 from both sides, and you've got x is equal to 6. So we've got x is equal to 6. So right there, let's look at A. Oop, whoop, sorry. They used y, those sneaky devils. Okay, so this is 2y. So y is equal to 6, okay? And which we have right there. Okay, this is not going to be right. Okay, let's see what 12 is equal to. So x, or this side here, the hypotenuse, is equal to 2 times y is equal to 2 times 6 is equal to 12. So x is equal to 12. So D is our answer. Okay, so again, you needed to know the 30, 60, 90, and then the tricky part was applying it here. And I probably should have drawn my triangle in the same orientation as that one. It would have made it easier, and I wouldn't have had that initial mistake. Okay. So here's some trig for you. So it's asking you to find the tangent of angle A and the tangent of angle B. So let's remember the formula for tangent is tangent of theta is equal to TOA. TOA is opposite over adjacent. So angle A, let's take that one first. So this is angle A. Now, the question is, what are the definitions of these legs? So 24, A to B, is the longest leg, so this is always going to be the hypotenuse. Okay? But from the tangent's perspective, or from angle A's perspective, okay, the opposite angle is going to be 26, and its adjacent leg, opposite leg is going to be 26. Its adjacent leg is going to be 10. So the tangent of A is going to be equal to 26 over 10 is equal to 2.6. Okay, so let's change colors. And, I'll erase all this. Okay, so now we're going to look at tangent of B. So now we're looking at it from the perspective of angle B. So 24 is still the hypotenuse because it's the longest. Okay. 10 is opposite B, so that's the opposite leg. And 26 is next to B, so that's the adjacent leg. So the tangent of B is going to be the opposite, which is 10 over 26. Okay. Which is equal to 0.38. So we look for our answers here, and sure enough, tangent of A is 2.6, tangent of B is 0.38, so our answer is B. Okay, so this is an exercise in knowing what the adjacent opposite is for the angle that you need. Okay, so that's a good example. Okay, find the approximate area of the triangle. Okay, so let's check and see. Do we have special triangles here? And it tells us that this angle is 40. Darn. So it's not a 45, 45, 90. It's not a 30, 60, 90. It's a 40, 90 something. Okay, we have no idea what it is. So, or actually, we do know what it is, right? So because we can add 40 and 90, we get 130. We subtract that from 180, and we actually know this is 50. So it turns out we don't need to know it, but that's okay. So, but the thing is, I can't use any of the special triangle formulas. I've got to use trigonometry. Okay. So here I have 40 degrees. So I need a trigonometry formula that is going to use the opposite to 40 and the adjacent to 40. So what would that be? We just did it. It would be the tangent. So tangent of 40 is going to be TOA, T-O-A, the opposite over the adjacent. That's going to be equal to x over 6. So now we look in our handy-dandy tables, and we find out that the tangent of 40 is equal to 0.839 is equal to x over 6. So x is going to be equal to 6 times 0.839. So it was equal to 5.03. Now, look at this tricky thing that they did. You might go, oh, I found X. I have my answer. And you look up here and, yep, sure enough, there's 5.03, and you mark that as your answer, and you would have been very wrong. Why would you have been wrong? Because the question asked you to find the area. Okay, it didn't ask for X. Okay, you need to find X in order to find the area, but that's not what the question asked for. Okay, so we know that X is equal to 5.03, so our formula for the area is 1/2 base times height. Okay, so it's going to be equal to 1/2 6 times 5.03 is, long story short, is going to equal 15.09, and the good answer is A. Remember how the tenths and the hundreds, if they're close, that's good enough, and we got 15.09, and it's closest to 15.1. It's definitely not close to 45 or 30. Okay, and we already know B is wrong. Okay, so that's how you would do this problem. And again, the tricky part is that you didn't just need to find X, you needed to find X, and then you needed to find the area. Okay, this is similar, sine F and sine G. And we remember what the formula are for F and G. So sine of theta, okay, is so, as in SOHCAHTOA, is opposite over hypotenuse. Okay. So the easiest thing to start with is which is our hypotenuse, and the hypotenuse is always the longest, so our hypotenuse is going to be equal to 100. Okay, so sine of F, where's F? There's my angle F. I need to figure out which is the opposite. Okay, 28 is next to F, it's not the opposite. Okay, 96 is the opposite. So the sine of F is 96 over 100 is equal to 0.96. Okay, so sine of G, okay, here's my G, and my leg that's opposite to G is 28 over 100. That's equal to 0.28. So we look at our choices here. We have sine of F is 0.96. Sine of G is 0.28. Bingo, we got D. Okay, so simple application of the sine formula. Just, you got to make sure you know what your opposite is and be careful what angles you're looking at. Okay, so which expression could be used to find the value of X in the diagram? Now, this is a little tricky. So here's X, and X is the hypotenuse. Okay, now the angle we're given is 35. Okay, but then we're given 12. And 12, so what you'd like to say is the sine of 35 is equal to 12 over X. And you'd solve for X and everything would be fine. But, alas, you look at all the answers and they're not giving you sine. They want cosine. Ugh. So what to do? So this is not going to work. Okay. So we need to calculate that third angle because we need to use cosine, which needs this angle because you need to do the adjacent over the hypotenuse. Okay, so let's get rid of this. So, how do we figure out that angle? No problem. We have 90 degrees here, we have 35 degrees here, so it's going to be 180 minus 90 minus 35. And that is going to be equal to 55. Okay, so now we have this angle. Okay, and the formula for cosine theta is COA, co, okay, C opposite, and it's not A, it's H, over hypotenuse. Okay, so my cosine of 55 degrees is going to be equal to the opposite, oh boy, I'm blowing this one, huh? It's the A, good grief, Liza. Adjacent. I didn't learn it as SOHCAHTOA, so I'm having to adjust, and it's ugly sometimes. So my adjacent is going to be equal to 12, and my hypotenuse is going to be equal to x. So let's look around here and see we have cosine of 55 here, we have cosine of 55 there. We say it's 12 over x, here's 12 over x, this one's x over 12, it's a no-go, so it's got to be A. Okay. So, what is not enough given information needed to solve a right triangle? Okay. So, what do we mean by solving a right triangle? Okay, to solve means find all angles, the measure of all angles, and all lengths. Okay, so let's look at here. How would we be able to find all angles and all lengths? Notice that it does not ask you to find them, it just asks how you would find them. So if we were given two acute angles and one side length, let's say A, okay, could we figure out all the angles and triangles? And sure, we could, okay? We know these two angles, we know this one is 90, so we've got all our angles, and now all our lengths is we could use trigonometry to figure out, once we knew the angles, we could use trigonometry to fill out the sides, okay? So A is not the right answer because it's asking for what is not enough. Because you can solve a right triangle if you know two acute angles and one side length. So what if you only knew the measure of the hypotenuse? Okay, that's not much information. And sure enough, there's no way you could find the angles because all you know is that this angle down here is 45. There's no way you can calculate the others. Okay, and you know absolutely none of, well, you don't know the sides, but you do know the hypotenuse, and that's not going to help you find the other two. So the answer is B. Okay, if you have just the measure of the hypotenuse, you cannot solve a right triangle. If you have two side lengths and then you have that one angle, you can figure it out using trig. And again, one side length and the measure of one of these other acute angles, you can use trig. Okay, so B is the correct answer for 14. Okay, 15, measure A. So we're going to find the measure of angle A. So here's our angle A. Okay, so if we look at A, we have, see, 6.5 is our hypotenuse. This is our opposite, and the x's are adjacent. So we find what handy-dandy formula uses opposite and hypotenuse. Okay, obviously that's the sine. So the sine of A, we'll do the general case for sine of theta, equals opposite over hypotenuse. Now we fill in the information we have. So the sine of A is equal to, opposite is 3.5, over hypotenuse is 6.5. So sine of A is equal to somewhere between 32 and 30, or sorry, no, that's exact numbers, is 0.5385. Now it's just a simple calculation. Now, how do you find the, did I put it in here? No, I didn't, darn. Okay, so we have, sorry guys, I don't like it that they erase things. Okay, so we have sine of A equals 3.5 over 6.5 is equal to 0.5385. So what you need to do is, on your trig tables, you're going to go down the sine column. You're going to and you're going to find the number that's closest to 0.5385. Okay, and it turns out, then you're going to go over, you're going to read the angle, and it's right between 32 and 33. So a good guesstimate is 32.5 degrees. And here we have 32.58 degrees, which is answer B. So in this case, what you've done is you've kind of used the trig table in the opposite way, in that you know what the trigonometric function is, you know what that answer is, and you need to find the angle. And so you go down the column for that function, and then you can find your angle. Okay, that's it. That's a long review of Chapter 7, but please make sure you understand all this stuff. And if you have any questions, please ask.